See you, Jay.
Jay.
So from my side, I have a modification of the raw VM.
Oh, nice.
I was trying to make the deploy directly from rolling, and it's not really too big a problem. But the problem is with the project dependencies inside the project. Yeah. So because currently the system processes are located in the rolling project, and Casper project depends on rolling, and if you want to make a deploy, you must depend on the Casper. So this is like a cycle dependency. So I was only able to just print or print the source code from directly from the contract. So I can show them.
Okay, hold on. That's super interesting though. So you were going to try to, maybe I misunderstood. Were you going to try to deploy, like write some Roland code that then deployed other Roland code back to the same node?
The same or any other, yeah.
Or a different one.
Yeah, okay. You just specify, the flow limit and the flow price, and
you might not need to. You might not need to depend on all of Casper though, if because gRPC is really the thing, right? That you need.
Yeah, but how now this is a part of the Casper project. So yeah. This should be separated in the.
Oh, I see the problem.
Project. Yeah.
The problem is that stuff got mixed up in Casper in the first place.
Yeah. Okay. Because now you have an interface or trait inside the Casper project, and implementation of multi-parent Casper, which is used now, it's also inside the same project. So you have the implementation and the interfaces.
Yeah. I gotcha. Okay, cool.
Would you like to see that, or?
Sure, yeah. We want to see whatever you got to show.
Okay, so let me see. So what do I need?
Oh, Isaac, I see you dropped a document, the space-time calculus.
Those are just the slides that Greg had to go along with his presentation.
Oh, cool.
Yeah, it looks like they're also available on that the podcast page. I didn't realize that.
Cool. Oh yeah, did you go over those slides?
Only a very little bit.
Oh, okay. Oh, gotcha.
I just want to make my fonts a little bigger. This should be fine. I was thinking that maybe I can go to the code, or you just want to see the result. Maybe I can show the result first. So here's my example. And I'm using this match construct to have like a variable here. So I created this special name, which is serialized, and it's really it really means get me the string version of my code.
Oh, cool. Okay.
So I'm just this is like a example of the code, and I'm matching this code to get it in this variable. So I could also do it like this directly, right? Oops.
Yeah, I just send that whole thing in there.
Mhm.
Yeah, but it's very nice to have like a variable, and you can just put it here.
Yeah.
So the idea is that with this serialized channel, I can send some rolling term, and of course I can get this returned back on this channel. And I'm using output to just print the result.
Oh.
So at the result, I want to see string of this code. So this will not be executed, it will only print it out. So let's do it. So here is the string of the code.
Oh, nice.
And like this is the first part to send this string to other node.
That's right. Yeah. Then the next part is just the over the wire part.
Yeah.
Yeah.
Although I will show you this why I think that it's not necessary to have a string. You know, you can send a gRPC code, but there are two different worlds. BNF syntax generate different types from the code that is received via gRPC. So this is not the same thing. I was thinking they are the same, but yeah, I realized no, this is not the same thing. So the easiest way is to use existing everything as it now, but just to send the string. And this pretty printer is not completely correct. I mean, completely it doesn't print everything. So if I paste this back, I'm missing these two.
Oh yeah.
I'm not sure how to say this extra data.
Yeah.
But I think this is only just about printing, nothing else. So when I put this back for X1, it's HTTP, and I'm using this HTTP from the last.
Yeah, right.
And H0 is no. H0 is acknowledgement, and H2 is output, right? And now I can execute this code. So I was just copy pasting this code, right? And it works.
Status. Yeah, nice.
So this is how I was thinking about deploying. You know, just like a regular gRPC call inside the rolling, and you can do whatever you want. And yeah, I can show you the code. So the main change is in the system processes inside the rolling project. This is the code. It's really pretty simple. I'm just using the existing pretty print function, and I'm just returning back this string. So in this project, now what I need is a calling deploy. And currently you have two different things about gRPC. On one side is a server that accepting calls from outside, and this REPL, this client gRPC, which is used by deploy. So in the main node, this is the entry point. So when you look, this is the deploy command that is doing the deploy to other project. and the other part is starting gRPC server. I think it's down there.
Oh, Tomislav, it's super nice that you're doing this in Scala, because all of their stuff for like signing deploys and stuff you can just use. You don't have to like bit twiddle until you get your signatures to match.
Yeah. The only problem is that I don't have a reference to all of this stuff where I need it.
Oh, because of the dependencies you were talking about.
Yeah, because inside system processes, you cannot easily call this code.
Yeah.
Sorry, this is inside multi-parent Casper documentation.
Well, I mean, at some point, like if you were to, I don't know how big of a challenge it is to fix that, or like clean up that dependency graph, but that would probably be a welcome pull request against the, against our chain.
Well, for me, this is a little challenging, because I don't have experience in Scala, so managing dependencies and all these libraries for me is it's like the biggest challenge.
Yeah,
not the code. Because for this HTTP, I was using this Scala J HTTP. I added this external dependencies. Yeah, I was trying this. I added these external dependencies, but this is not the best library for HTTP. So
yeah,
there should be like a better option. So for receiving not receiving for deploying, I was there are two options, right? I was thinking one option is to modify a little on the server side, and other option is to modify the sender.
Oh, you're saying you might be able to modify the service that actually receives the deploy?
Yeah, and why is that? Because I will show you exactly that, because this is like a very clear thing.
Why do you need to change it instead of just using it?
So because of this string.
Yeah.
So you're receiving something. Let me see. Validate deploy. So deploy. So this code is receiving deploy data from other node, right?
Yeah.
This is not sending. This is like a server. This is receiving.
Totally. Yep.
And this term is a string.
Yeah. Right. Right.
And let me see. This server code and client code is like new to me, so I'm confused. I'm in the client side or server side, because I'm looking where this code is parsed and transformed to AST, and it should be done here, but somewhere is the parse command. No, this is the sending part.
No, is it?
Service.
Oh.
Because this is do deploy. This is definitely sending. Yeah. This is Monix service. This is like a task that is created, and this is deploy.
So I was wondering about, you seem to be getting good at adding these system processes. I wondered if there was such a thing as, like, instead of having the system access always be persistent listens, like, fors or contracts or whatever, can we have persistent sends that represent, like, maybe something like a current timestamp or other block parameters? Like, it seems like having those things be sends rather than listens that you have to query and then get an answer back might be a nice thing to include.
Oh, so you're saying not since the process as an input.
Yeah.
Oh, yeah. Yeah, this is interesting for example, standard input, right?
Yeah, exactly. Yeah, standard inputs are Great example.
I'm not sure.
Maybe not in a blockchain context.
Yeah, yeah. Do you know, is there any existing?
They're all contracts.
Yeah, contract is just a trade, or
Okay.
or oh no, it's represents this sequence of terms or parts.
Oh wait, how do I read that time now?
Well, this is just the definition of a type, and
What does the double arrow mean? It's a function or a functor or something?
I'm not sure if this is like some kind of constraint or something. I'm not sure.
Yeah. Well,
Is
okay,
this
but it's a
like
sequence.
type alias or something? I'm not sure.
Yeah, I shouldn't pretend that I can read Scala. That's a losing game, I'm pretty sure.
Yeah, for me, this is also like Scala has so many different way of doing things. So, yeah.
Yeah.
Or this is like a function type. Maybe this is function type.
I wondered in JavaScript.
Oh, yeah. This is a function type, right? When you look here, they are all representing this type. So serialize, all of this is this type. And
okay, so it's a function that takes in.
Yeah, and when you look here, this is how it's used. So I suppose this is this sequence defined for this type. And this is contract call, probably, yeah, second parameter is this sequence. And this sequence is probably exactly that. Or the whole yield is this type, I'm not sure.
What is the stuff in the sequence? Oh, you're just looking at a specific one. The sequence is the parameters that you pass in.
Yeah.
Right, when I call verify signature.
Sequence contains contains the parameters.
Yeah, okay.
So,
right. What's the produce?
And the produce is a function that you that accepts something that you want to return back. So in the first argument is the sequence of returning parameters, returning arguments, and
has type par. That usually just means
this
like
is
a channel.
This is always this is like a return channel.
Yeah.
But I'm thinking
you said this is you sending back the like calling produce, sending something back into the tuple space, right?
Yeah, and this is what you will receive here. When you do HTTP,
yeah,
this is the return channel that you will get your information.
Right, and so that produce call we were looking at was like that was the send that's going to come with your line 5.
Yeah, exactly. And this res, like result, is exactly
that part. Yeah. Oh yeah. So it's funny to read that it's produce message then channel, like not channel then message. I don't know why.
Yeah, exactly. Yeah.
Okay.
Yeah, exactly. This is like the channel, and this is the parameters sent on this channel.
Yeah, totally. Oh yeah, I'm glad we're looking at this because registry lookups is coming up soon for me as something to implement.
Cool.
Yeah, good. All right. Did you say you had another thing you wanted to show?
Oh, another thing is my code on uh, for Haskell.
Nice.
I have a new implementation for Arabic numerals, which I want to show, but
Oh yeah, that's right. Yeah.
but I also modified the existing implementation for rolling 5. So
Oh wow. Okay.
I'm more excited for that because I don't have dependency on initial type anymore inside the parser. So I'm very happy for that.
Okay. Wow. Okay. Cool.
And yeah, now I think I have like the correct implementation what Greg was asking. You know, with I also have Roman numerals, and I have like 2 monoids connected together, not like everything in one place as I had before. If you remember, I have different implementations, and here I have all these things together. You know. And the generators with digits and addition and everything is together, which is not what Greg was explaining.
What is AN4? Oh, new type AN4.
I'm just wrapping these multiset. This multiset calls lists, and it's pretty confusing because everything is in one place.
Okay. Okay. So, gotcha. But now you have a better one.
Forget about that. Yeah.
Okay. Yeah, nice.
So now I have these 2. First, I have these 2 monoids for different numerals.
Okay. So the top one, it says Arabic numerals, is represented as basic digits and monoid with 0 and binary operation. So these are your digits, these on line 10, right?
Yeah, and I'm not specifying 0 and this binary operation. I'm just saying there is there must be 0 and monoid operation, this binary operation. It's just saying that this is. I'm not using my type class for specifying this. I'm using existing monoid type class.
Okay.
And this monoid type class has two methods: mempty, which is 0 unit, and this binary operation, which is whatever you want to be. This binary operations. It's part of the semi group, but mono it's already semi group.
But in your case, this diamond operator is going to be mash them together to make a 2-digit number.
Exactly. And I'm not using the special character for that. I'm just saying, okay, this is like a monoid for Arabic numerals. And this is exactly what Greg was explaining, right? This is like the first language is the first monoid is the language of digits, and addition will be second language where this Arabic and Roman numerals language will be just it will be parameter to the second monoid. So Roman numerals are almost the same. They have their own digits, but I found out that 0 is sometimes it's part of the Roman numerals, but sometimes not. So I just declared as a semigroup without 0. So
what is it? Remind me what a semigroup is and how it's different from a monoid.
Semigroup is this diamond operation.
That's it, just some binary operator. No.
Yeah, and monoid is just semigroup with this diamond and extra 0.
Oh.
And nothing else, really, nothing else.
Okay, yeah. So the 0 is the difference, just having an identity element.
Yeah. Addition, language for addition. This is just a monoid. It's exactly monoid. There is nothing else. Addition is really just a monoid. And I mean, it's just a monoid with different numerals that you can add. But I'm not depending on anything. I'm just saying addition is a monoid.
Yep.
And these two type classes are are this like a extension that can be used to combine different languages. So in this definition, there is no dependencies between. So in implementation, this will be combined together.
Okay.
So for each Roman and Arabic numerals, I have two files. One is semantics, and one is the syntax. And maybe I can show you the syntax or the parser. It's totally simple, right?
Okay, cool.
For each of the numerals, I'm calling one function from this definition. Maybe I can put it here. For each parsing expression or for each character digits, I'm just calling one of the constructor.
Yeah. Oh, okay. So those on line 10 on the right side, those are functions? No, those are just values. Those are just like 9 discrete values that can exist.
Yeah, but if you think about this as a creator of something that will be implemented as Arabic numerals, they're constructors. In that sense, they are like a functions. But yeah, you're correct. They're not Haskell functions, but
Okay.
yeah, they're constructors which are just values. Yeah. So
yeah. They're like functions with no arguments, basically.
Exactly.
Yeah.
This is why I'm using this operator, which is just mapping without forgetting.
Throw away the right side.
Yeah, and the digits is just a choice between all of this, and one digit is just a choice about between all of this, and the digits are just changing all of these digits with a binary operation.
Yeah, okay, so chain 1 is some function that you're calling as a infix function that came from parsec or something that's saying like, if you parse a bunch of digits in a row, that just means it's a multiple digit number. I'm joining them all with this binary operator that matches digits.
Yeah, and I could join it with another parser in between. You will see for a plus, I'm using the same function chain 1, but I'm using another parser for a plus in between, right? But here you don't have anything in between. They are just not even space. They're totally combined.
Yeah.
For Roman numerals, everything is the same. Just the digits are different. But they're also using the same thing.
Okay, yeah.
And but you don't see 0 here.
Right.
It cannot be implemented because it doesn't exist.
Oh wait, was that in? How did you do that in the Arabic ones? You used the 0 from the monoid or empty or whatever it's called.
Yeah.
Oh yeah, I didn't notice that carefully enough the first time. Okay, yeah, cool. That's awesome.
So this is the syntax and semantics. Semantics is really instances for these type classes, and definition for initial encoding, right? For abstract data types that will be filled with the parser. And this is also like a very straightforward. First of all, we have this recursion in types. So this can be seen as Arabic numeral, like a data type, can be a list of exactly the same type, or one of the ground terms, like the digits.
Yeah,
And,
right. Okay. And the list one is the multi-digit number.
yeah,
Okay.
this holds like multiple digits.
Got it.
And this is like really nice because this is exactly what Greg was explaining.
Oh. Now you're making, I see the next part. So now you're saying you're making an instance, right? So you're making this AN thing, data type that you defined above on line 8, actually be an instance of your Arabic numeral semantics, which I'm looking at on the right side of the screen.
Yeah.
Okay.
And here is the connection, right? This is like this is why Oleg Kiselo calls this semantics or syntax semantic interface, because it's somehow in between the syntax and semantics.
Yeah. You said you made that name, or who thought of that name?
Oleg Kiselo. This guy that I mentioned from Final Tagless.
Yeah, yeah. Nice.
And then, now we're creating instances for the Arabic semantics class.
And
yeah,
0 too.
I must create instance for monoid and semigroup for zero and the binary operation. And I like this because here's the definition for the binary operation, which is semigroup, and here is exactly what this operation is doing. When you're parsing, this is what is going to erase this syntactic difference that we have.
Oh, so with semigroup, you had to explicitly tell it that when you see a 0 as part of one of these binary relationships, here's what it means, throw it away. Whereas with monoid, that's already part of the definition of monoid. So all you had to say is M-empty is this particular A01.
Yeah, because monoid is only definition for monoid is M-empty. So I only need to say what is the 0. Okay. And this is how you think about that. You're saying I'm putting constraints on this class, which is like a monoid. So you must say what is the binary operation for your data, and what is the 0 operation.
Yeah.
But in a sense, this is like the same thing as user-defined type class, just different functions.
Yeah, gotcha. Okay, so what's the stuff down lower? Yeah, like 23, 24.
Yeah, this is just a helper functions to evaluate the terms. So for Arabic ints, I'm evaluating this AN data type to list of integers. In a sense, I'm saying I need. I could evaluate this in whatever I want, but in the second step, in the addition language, I'm accepting integer. So I want to have this implementation that gives me that evaluates AN to integer.
Yeah. Okay. Yeah. Makes sense. Makes sense.
And this is just a recursive definition to get all the elements. And how I get integer, I'm using index in the list, because this is how Arabic numeral is working. So I'm just saying, and I'm using this from just which can get exception, but it's really, this code is safe because you only have this much of Arabic numerals, so you will definitely have it in
from just unwraps your maybe is what you're saying, right?
Yeah. But if it's nothing, it will get to runtime error. But it will never happen.
Yep. Okay.
And I can interpret this. I can this eval is just create me from this list of integers, create me one integer which is
oh yeah, right.
From these digits. And yeah, I'm using this Haskell already.
Yeah, nice. Okay.
And show an is different evaluation. This will evaluate a list of integers and not the final result. Because I want to have like a pretty print which will print the characters and not the final result. But is this the same in this case? Maybe this is like a very simple example to have this different.
Yeah, I get the idea. I mean, they're at least different in the sense that show an gives you back a string, although show on eval an might give you that same string.
Yeah, and then in this case, I'm using the list of ints. But when you combine this int in one integer, it will be the same. Yeah. But you can imagine like a more complicated example when you want different strategy for evaluation, different for pretty print.
Totally. It's actually kind of a nice, like this would be a nice exercise in a textbook. Implement it both ways and convince yourself that they're the same.
You will see I have both of these implementation already. So you can print the final result and the like a pretty print.
Nice.
I'm going to have to take off, guys. So the recording will end. I was hoping we would get to a Roxy update.
Oh yeah. Well, we'll start recording. We'll see if we get that far in. But definitely, Jim, I'm always interested in talking about Roxy. So you won't have to twist my arm. Yeah.